Hello everyone. In this video, I will be sharing some details about graphene. In the description of this video, you can find the link for the graphene playlist to watch the latest news about graphene. Graphene is a one-atom thick layer of carbon atoms arranged in a hexagonal lattice, that is honeycomb lattice. Graphene is called as wonder material because of its unique combination of exceptional properties. It is not only the thinnest but also one of the strongest materials. It conducts heat better than all other materials. It is an excellent conductor of electricity. It is optically transparent yet so dense that it is impermeable to gases. Since its first demonstration in the year 2004, graphene research has evolved into a vast field. Monolayers of graphene stacked on top of each other form graphite, which is used as lead in the pencils. Since a typical carbon atom has a diameter of about 0.33 nanometers, there are about 3 million layers of graphene in a 1 millimeter thick sheet of graphite. Graphene strongly absorbs light of all visible wavelengths, which accounts for the black color of graphite. Yet, a single graphene sheet is nearly transparent because of its extreme thinness. The material is about 100 times as strong as would be the strongest steel of the same thickness. Scientists theorized the potential existence and production of graphene for decades. It has likely been unknowingly produced in small quantities for centuries through the use of pencils and other similar applications of graphite. In the year 2004, the material was rediscovered, isolated and investigated at the University of Manchester by Andrew Gimm and Konstantin Novoselov. In the year 2010, they were awarded the Nobel Prize in Physics for their groundbreaking experiments regarding the two-dimensional material graphene. High-quality graphene proved to be surprisingly easy to isolate. Graphene is available in various forms like monolayer sheets, bilayer graphene, turbostatic graphene, graphene superlattices, graphene nanoribbons, graphene quantum dots, graphene oxide, graphene fiber, 3D graphene, pillared graphene, reinforced graphene, molded graphene, graphene aerogel, graphene nanocoil, and crumpled graphene. A rapidly increasing list of production techniques have been developed to enable graphene's use in commercial applications. Isolated 2D crystals cannot be grown via chemical synthesis beyond small sizes even in principle because the rapid growth of phonon density with increasing lateral size forces 2D crystallites to bend into the third dimension. In all cases, graphene must bond to a substrate to retain its two-dimensional shape. Graphene can be obtained from different kinds of approaches. Small graphene structures such as graphene quantum dots and nanoribbons can be produced by bottom-up methods that assemble the lattice from organic molecule monomers, example citric acid, glucose. Top-down methods, on the other hand, cut bulk graphite and graphene materials with strong chemicals, example mixed acids. Gimm and Novoselov initially used adhesive tape to pull graphene sheets away from graphite. Achieving single layers typically requires multiple exfoliation steps. After exfoliation, the flakes are deposited on a silicon wafer. Crystallites larger than 1 mm and visible to the naked eye can be obtained. Graphene can be obtained from coal, food waste and even plastic waste using flash joule heating method, which involves electrothermally converting various carbon sources into micron-scale flakes of graphene. Graphene is a transparent and flexible conductor that holds great promise for various material device applications, including solar cells, light-emitting diodes LED, integrated photonic circuit devices, touch panels, and smart windows. Smartphone products with graphene touchscreens are already on the market. Graphene is often produced as a powder and as a dispersion in a polymer matrix. This dispersion is supposedly suitable for advanced composites, paints and coatings, lubricants, oils and functional fluids, capacitors and batteries, thermal management applications, display materials and packaging, solar cells, inks and 3D printers materials, and barriers and films. In some places, already people started using graphene to increase the strength of concrete. Researchers are studying graphene toxicity. A study showed that the toxicity of graphene is dependent on several factors such as shape, size, purity, post-production processing steps, oxidative state, functional groups, dispersion state, synthesis methods, route and dose of administration, and exposure times. Because of the toxicity claims, Canada banned the use of graphene-based face masks.